In AP Physics, an angle of launch always has two initial parts. The horizontal component is v0 cosine theta, and the vertical component is v0 sine theta. These two components are completely independent. Watch the velocity vectors carefully. The horizontal red arrow never changes because there is no horizontal acceleration. But gravity pulls down, constantly changing the vertical blue velocity. How does the launch angle affect the path? As the angle increases, the maximum height goes up. But to achieve the absolute maximum horizontal range, 45 degrees is the perfect sweet spot. Right before hitting the ground, the object has two velocities, the constant horizontal velocity and a maximum downward vertical velocity. Connect them, and use the Pythagorean theorem to find the true final impact velocity. Here is your absolute projectile motion cheat sheet. Step 1. Resolve your velocity components. Step 2. Apply the main formulas for total time, maximum height, and range. And finally, the trajectory equation links the y and x coordinates directly. Pause the video and take a screenshot. Relative velocity in 1D. In the ground frame, object A is moving to the right at 5 meters per second, and object B is moving to the right at 2 meters per second. Now, looking from the frame of object B will consider itself stationary. At this point, the relative velocity of object A will be 3 meters per second. Now for the riverboat problem. Case 1. To cross the river in the shortest time, the boat must be steered straight toward the opposite bank. However, the river current pushes it diagonally, which is called drift. Case 2. For zero drift, or the shortest path, the boat must be steered at a specific angle against the current. As a result, the net velocity of the current and the boat points straight to the opposite bank. Finally, the Rain Man problem. The rain is falling straight down with velocity vr. A man is walking to the right with velocity vm. To find the relative velocity of the rain with respect to the man, we reverse the direction of the man's velocity. Then, we find the resultant of vr and minus vm. The magnitude of the relative velocity is the square root of vr squared plus vm squared. And the angle theta is tan inverse of vm divided by vr. To stay dry, the umbrella must be held at this exact angle theta with the vertical. Next up, we'll dive into dynamics. Subscribe so you don't miss out.